Welcome to this video. We are going to briefly take a look at how solids, liquids, and gases differ from each other. Now we're going to look at two crucial aspects. Those two aspects are intermolecular spacing and molecular speeds. The spacing is basically how far apart are molecules, and the molecular speeds is just how fast are they going. Okay, so here's a gas, and I'm actually going to choose this gas instead. Let's watch and see. There it goes. Now you can see that when they bounce off each other, they kind of vibrate a little bit back and forth, like that one there was vibrating, you can see it. And there are little lines, you see those little dotted lines? That shows that they're pulling on each other. They're close enough to pull on each other when those dotted lines are shown. So what do you think? Are these going fast? This is a gas. Are the gas molecules going fast, high intermolecular speeds? What about their spacing? Is it far? Is it small? We're going to answer those two questions by comparing to a liquid. So you just saw a gas, here's a liquid. Let's watch. Are these going faster or slower? Are they spaced farther apart or closer apart? Again, those little dashed lines show bonds. It shows forces of attraction between the two molecules. Okay. Alright. And now let's look at a solid. So here's our solid. Are those molecules moving fast? Are they moving slowly? Are they close together? Are they far apart? So when you look at them side by side, solid, liquid, gas, now you can start to answer the question, which are moving fastest, and which molecules are farthest apart. There is a rule that says the farther apart molecules are, the more potential energy they have. The faster they're going, the more kinetic energy they have. This idea that molecules have more energy, potential energy, when they're farther apart, it's really similar to another idea we've seen. If you take a ball and you hold it above the ground some small height, it's not very far from the ground and it doesn't have that much potential energy. But if you hold the ball much higher up, much farther from the ground, it has more potential energy. As it turns out, these molecules are no different from the ball hanging out of the window. The farther apart they are, the greater their potential energy. The closer together they are, as in solids, the smaller their potential energy. Similarly, the faster they're going, as in gases, the greater their kinetic energy, and the slower they're going, as in solids, the less their kinetic energy. One of the concepts we'll work with in this unit is internal energy. Internal energy has the variable U, capital U, and it's the total potential energy and kinetic energy of the molecules making up a substance. So if your ball is hanging high above the ground, we're not talking about that potential energy in this definition. We're talking about the potential energy because of how far apart the molecules are spaced. And if the ball is going really fast, it's been thrown really fast, that's not the kinetic energy we're referring to in this definition. We're referring to that random kinetic energy of the molecules bouncing around.